In this video, we will go over how the leading coefficient affects the graph of an absolute value function. I have 4 graphs here. 2 of them are opening upward. So look, these 2, they open up, right? So what do we know? Their leading coefficient or their coefficient, this A value and B value, they must be positive. If a graph opens upward, we know that these coefficients must be positive. Oh, sorry, you couldn't see what I was writing down. Our first part is asking you, for each coefficient, state whether it is positive or negative. I said A and B must be positive because the graphs are opening up. Okay, I'll say graphs open up for these 2, right? Now, the other guys. The graphs with coefficients C and D. Notice they open down, right? So C and D must be negative. So by looking at the direction of their opening, we can tell if these coefficients are positive or negative. Now the next question, that's the tricky one. Now let me see. Do you agree with me that positive numbers are always bigger than negative? Right? That's true, right? Because the next question is asking for this. Which coefficient has the greatest value? Okay? And what I'm going to do is I'm going to completely throw out C and D. Why? Because C and D are negative numbers. Negative number cannot be the greatest number when there are 2 other positive numbers, right? So when they're looking for the greatest value, it's either A or B. But the question is, which one is it? Now, the greater this coefficient is, the narrower the graph will be, okay? So I will say, no, I think I should erase this X mark though. It's either A or B because they are positive, but go with the narrower. Oh, if I can squeeze that word in. Go with the narrower because the narrower the graph is, the bigger that the coefficient is. So let me see. I'm gonna go to move this up a little bit. So which graph is narrower? One on the left or one on the B? This graph is narrower, right? So A must be, this graph is narrower, so A must be bigger than B. So we say A is the greatest value. B will be the second greatest because this is the second positive number. But if you just look at the number, instead of the signs of it, this C, the absolute value of C will be the biggest because this one is the narrowest, right? But because they were asking for the greatest value, we only looked at 2 positive numbers. Because C and D were negative, they can't be the greatest number, right? They are the smallest numbers here. All right, next question is asking for choose the coefficient closest to 0. I wish I had more room to write here. Closest to 0 means the graphs will be the widest. And it can be close from 0 from the positive side and from the negative side, right? So the sign doesn't matter this time. So which graph, the direction doesn't matter, like which opening up or down doesn't matter. Which graph looks the widest to you? The one with D, right? So this graph will be the widest graph. It was tricky because for the second part, part B, we had to look for the sign. But for part C, when they simply ask you for closest to 0, it can be both positive or negative because it can be close from the positive side or the negative side. So all you had to do was just go with the widest graph out of these 4. So that's how I would do this goal, the objective in Alex homework. Just really applying what we talked about this part during class. which I already scanned and posted on Canvas for you, but we did say that we will have to, so these are the work that we did that day during class, but we ran out of time, so I said I will record and post lesson videos on the rest of the pages by this Thursday. So I came back and did that first part. Let me go over about 3 graphing problems with you, and that will conclude section 1.6. Let's graph this function. Let me copy this. Y equals negative 2 over 3 times absolute value of x minus 2 plus 5. So what I notice is that because of this plus 5 outside, the graph will be shifted up 5 units, right? And because of this minus 2 inside, the graph will be shifted right 2 units, right? So we do know where this graph will start. This pointy point, I'm going to move it. I'm going to move it up 5. Take a look. I'm going to go up 5. 1, 2, 3, 4, 5. And I need to go which direction? Right 2. So I'll go right 2. Right 2. And this is going to be the new point. And you know the graph will look, let's see, what else though? We need to have a couple more points because 1 point is not enough. We just know that pointy end will be up there, okay? After that, we just have to plug in some points. But for this problem, I think we can do something slightly different. So take a look. I'm going to go ahead and use this negative 2 over 3. Negative 2 over 3. Because this number is negative, this is going to open downward, right? This is going to open downward. It's going to be flipped, right? But I can do it this way. I can go down 2 over 3. Just plot my second point. So starting here, I go down 2 over 3. Here is my second point. And what I can tell is that my graph will go down that way. But I need to make a V shape. So what I can also do is I can go down 2 over 3 to the left to make that V shape. So I'm thinking the graph will look like this. Okay, the graph will look like this. But if you want to be sure about those 2 points, because what I did was I plotted a point at negative 1, 3, and I plotted another point at 5, 3, by just kind of looking at this as a slope. I said, oh, if it is negative 2 over 3, I must go down 2 over 3. So for me, that method worked okay. But for other function types, you know what's really good is you can use your XY table, okay? I'm going to go ahead and do my XY table. The first point that we plotted had an order pair of 2, 5 because we went 2 to the right, up 5. So I'll go ahead and put that in the middle though. Why am I putting that in the middle? Because for a V shape, we have a point in the middle. We should have something to the right of it. We should have something to the left of it to make that perfectly symmetric V shape. How did I get 5 though? You can check it by plugging into the function. So if I plug in 2 into the function, which is negative 2 over 3 times absolute value of 2 minus 2 plus 5, if I evaluate that, I will get 5. Just like that, I can plug in some other points. What will happen if I plug in 5? I can go ahead and plug in 5 into the function, and that will simplify it to be all that work. But listen, we can do this by hand. I know you can, but I do want to give you another tool though, okay? When I typed up that syllabus, I did say you are allowed to use your graphing calculator. Some of you bought a $120, $30 graphing calculator, but I know that we have a free tool, so I will show you how I can find these table of values on Desmos graphing calculator, okay? So what you will do is you will type in your function, y equals negative 2 over 3, absolute value of x minus 2. Oh, no, that's not an absolute value symbol. Absolute value of x minus 2 plus 5. Now, I hope you're watching. By the way, this looks a lot like my graph, right? That's perfect. But if I want to see some values that I can plot on my paper or on your Alex homework, you can click on this edit list button. Okay, this is called edit list, and then click on this table. They do the math for us. They just do the arithmetics for us. If I plug in -1, I will get 3 out. So I copy that down. What else? If I plug in 5 in there, oh, they don't have that, but let me go ahead and type in 5. The dx value will be, the y value will be 5. If I plug in 2 in there, the y value will be 5. So just like that, you can just keep on plugging in number. What will happen if I plug in x equals 8? I think it's gonna be another very nice number. If I plug in x equals 8, I will get the y value of 1. So that's your calculator that you can use, okay? So I will say you can use Desmos table function to find additional points. Okay, you can always do that. So, and that matches what I did by just looking at the coefficient as a slope. I have a point at -1, 3. I have a point at 5, 3. Okay, so that is how you can graph your absolute value function. And I'm kind of doing it in the mixed method, right? I use not only that transformation rule, but I also want to check it, and I also want to use the calculator to get the table of values, because the important point is this black dot. The red ones, I needed them to graph the line, but to find these red dots, these other points, I just needed to plug in some values into the function, okay? All right, let me try another one with you. B. Below is the graph of y equals square root of x. Now this time we are graphing a function that is y equals 2 times square root of x plus 4 minus 2. So I know what this minus 2 will do. This minus 2 will shift the graph down 2 units. Also, this plus 4 will shift the graph. Which direction? Left 4. And this 2. Now imagine, when you take a square root, you get a number, right? But if you double it, the y value will get bigger quicker, right? When you double something, it grows faster. So what I'm expecting is, you know how this graph is kind of slow at growing up or like getting higher? Our graph will increase at twice the speed, okay? So our graph, let me go ahead and plot the first point. So go down two from that original point and go 4 to the left. 1, 2, 3, 4. Here is my point. So my graph will start right here, but it's going to go faster. It's going to increase at a faster rate. So I'm thinking something like this. It's going to look something like this. But in order to have a more accurate graph, I need to have some values plotted. So I'll say my first point is at -4, -2. But I do want to plot some good points here, okay? 0 will be nice, because if I put 0 in here, 0 plus 4 will give me a perfect square. But, you know, like I said, if you want to find some table of values using a graphing calculator, I'm okay with that. Y equals 2 times square root of x plus 4 minus 2. So it looks like we got that starting point, right? We have a starting point at -4, 2. That's perfect. I can see that I have a point at -3, 0. So I'll copy that down. -3, 0. I'll plot that. What's another good point? I have another good point at 0, 2. And I think that may be enough. All right, I'm being greedy. Let me do one more. How about I open up the table of values? I don't need these decimal ones, but is there anything nicer to the right side of it? I don't know, maybe 7. What will happen if I plug in 7? That's not nice. How about if I do 10? Oh, that's not nice. How about if I do 3? No. Okay, maybe that's all. What about 6? No. 7, 8, 9, 10, 11, 12. Oh, look, when I plugged in 12, it came out nice. But I don't think my x-axis on the graph paper goes that far out. So I might have to stop there. Yeah. What if x is 1, 2, 3? So you know, guys, I really tried. Oh, I found one more. When I typed in x equals 5, guess what? The y value came out to be 4. That's a very nice point for us to plot. So when x is 5, y is 4. Oh no, my Apple Pencil stopped working. All right, let me pause the recording for just a second. It'll charge so quickly, so I'm back. So the other point that I wanted to plot was 5, 4. And you saw what I did. I tried to get as many points as I can, because the more points you have, the more accurate your graph will be. So that is how we can graph this square root function, okay? Alrighty, maybe one more. And this one is a cubic function. And after this, I'm gonna ask you to go and try these Alex homework topics. There are 13, and I don't think I went over 2 of them, like graphing a parabola and graphing a square root function. But hey, that was a square root function. So I think you guys are ready to start working on 1.6 homework definitely after this video. But here's the very last one. Let's use the transformation rule to start that, find that first point. Okay. If I look, I have a -3 outside. That will shift the graph down 3 units. I can also see there is -1 inside. This will shift the graph right 1 unit. So I see there is a point plotted here. I'm going to move that point in those directions. So down 3. 1, 2, 3. Right 1. Right 1. Here is that midpoint. Okay? But looking at the coefficient of half, the y value will go up at a half the speed as this original function. So we're gonna see something that is a little bit widened, okay? But in order for me to have an idea of what it looks like, I think I want to have maybe like 5 points on this cubic function, okay? I'll put this point that I just plotted. The point is what? 1, -3. I'll put that right in the middle. And my goal is to have maybe 2 points to the right and 2 points to the left. And I can just plug in random numbers like 2, 3. But the thing is, if I plug in 2, if I plug in 3, they may not come out so nice. And I'm thinking that because we have to take half of a number, right? Half of even numbers are nice, but if you have to take on half of an odd number, they may give us a decimal, and I may not like that so much. But you know, I'll still try. How about I try 2 and 3? And how about I try 0 and -1? I just pick these x values. If I don't have a calculator, I will have to plug these x values in myself and evaluate it. But I'm going to go ahead and use this tool that I have, okay? So I'll go ahead and type in y equals half times x minus 1 cubed minus 3. So, hey, look, at least we got that. Not at least, this is significant. We did this right. Look, we got that midpoint, 1, -3, right. Now, what I want to do is have enough points on my curve so that I can sketch this pattern, okay, sketch this graph. Okay, that's what I want to have on my paper. So let me open up this table of values, and I know what kind of x values I want. So I'll change these to -1, 0, 1, 2, and 3. And I'll just go ahead and copy these down first. So these are the numbers that we will get if we were to plug in these x values into the function ourselves. So I'm skipping some PEMDAS work. -3.5, -2.5, and 1. I'm going to go ahead and plot these points so that we can have a cubic function graph, okay? 1 to the left, down 7. 1 to the left, down 7. Wow, it's already down here. Next point is 0, but go down 3.5. 0, go down 3.5. Here it is. Next one, I already have 1, -3. The next point is 2 to the right, down 2.5. Here is this point. And the last point is 3 to the right, up 1. 3 to the right, up 1. And what I need to do now is connect these dots with a beautiful cubic curve. This will, oh, I don't like that so much. This will go down to the left, and this will go up to the right. But because I have about 5 points on my curve, I think this looks pretty good. I think I got the important parts of this graph right. But that is how I graph these functions. I plot the initial point using the transformation rule. And after that, I pick some random x values that will give me some nice y values for me to plot. So I want you to try these problems. This topic is called transforming the graph. Oh, whoopsies, I noticed a typo. If you could add an F there for me. Transforming the graph of a quadratic, cubic, square root, or absolute value function. That is the last topic that I wanted to go over in section 1.6 with you. 1.6 homework has about 13 topics, and there are 2 prerequisite skills that I wanted you to practice this week. You're expecting to spend about 2 to 3 hours on this section's work, but I will be back to teach you section 1.7 in separate videos.